Hi, in this video of Inkpot, I'm going to be continuing with the system of linear equations. We had left off at the case where m was equal to n and the you know determinant of the coefficient matrix was not equal to 0. So the first method that we had covered was the Cramer's rule. Now we're going to be discussing the matrix inverse method, because as you would recall, this implies that A inverse is actually existing. Okay. So yeah, so now when you're solving using the inverse method, the first few steps remain the exact same. You have a system of equations, you write out the coefficient matrix, you write out the constants matrix, and then you're supposed to calculate the inverse of this. Before calculating the inverse, you obviously need to check whether the determinant of the matrix is actually non-zero. So you calculate the determinant, which in this case is going to be 1 into -8 minus 5 minus plus 4 essentially is e into minus 2 plus 5 plus 1 into minus 2 minus 8. Okay, which in this case is going to be equal to minus 13 plus 4 into 3 plus minus 10. Okay, which is equal to minus 13 plus 12, which is minus 1, minus 10, which is minus 11. Okay, so this is clearly not equal to 0. Okay, so which implies that A inverse exists. Now that you know that the inverse exists, the first thing that you need to do is calculate the minors, which in this case would range from m11 to m33. I'm going to calculate a few here, and then I'm going to give you the solutions. So m11 is going to be precisely equal to minus 8 minus 5, which is minus 13. Okay, a11 on the other hand, because recall that 1 plus 1 is 2, which is an even number, so you essentially do not change the sign. So a11 is just going to be equal to precisely minus 13. m12 on the other hand is going to be equal to, so 1 2, it is going to be minus 2 minus plus 5, which is 3. A12 is going to be minus 1 into 3, because 1 plus 2 is 3, which is an odd number, so you change the sign, so which is equal to going to be minus 3. Okay, and so on and so forth. You can calculate all the minors and all the elements of the adjoint matrix. So you would have if I erase the ink on slide, you would have the following elements of the adjoint matrix. Now you can write out the adjoint matrix using this, and recall that A inverse is actually adjoint A upon determinant of A. Okay, which is exactly what you would have here. So you have A inverse, and now A inverse into D has to be equal to X, because recall that A into X is equal to D, which implies that X is equal to A inverse into D. Okay, so you can, so as I was saying, you will have X is equal to A inverse times D. So if you want to calculate X, A inverse is just going to be equal to minus 1 upon 11 into this particular matrix right here, which is minus 13, minus 5, 12, minus 3, minus 2, 7, and minus 10, minus 3, 16. So A inverse into the D matrix, which in this case is 16 minus 40 and minus 3. So you have 16 minus 40 and minus 3. Now this is just plain matrix multiplication, so you would have something like 16 into minus 13 would be minus 160 minus 48 minus plus 200, which is 40 minus 40 into minus 5, and minus 36. Okay, then you would have minus 48 plus 80 minus 21. Okay, and you would have minus 160 plus 120 minus 48. Okay, which is going to be equal to 160 minus 48 is minus 208, plus 200 is minus 8, minus 36 is minus 44. Okay, and then you have minus 48 minus 68 minus 69, so 80 minus 69 is just going to be 11. And then you have minus 160 plus 120, which is minus 40, minus 48, which is minus 88. Okay, and obviously you have minus 1 upon 11 right here. Okay, so this is just going to be equal to plus 4, minus 1, and plus 8. Okay, so x, y, and z are respectively x equals 4, y equals minus 1, and z equals 8. And this is how you would calculate it using the matrix inverse method. So this concludes our discussion on the two methods which are applicable only when the number of equations is equal to the number of unknowns and the determinant of the coefficient matrix is non-zero. Understand that these methods are only applicable under those two conditions, and the thing that we're going to do next, which is the Gaussian substitution method, that is going to be a universal method, and it's going to be applicable irrespective of the conditions on M and N. I know it feels like I have been saying this for a long time, but I just would like you to not confuse these things. So thank you.